Greetings, Earthlings. This is starting to look like a real computer at this point. As you can see, here is the PC board with most of the parts installed. This is the processor here. This is the memory. This is the I/O. And this is the video output section. I've left out most of the I/O chips for now, because we're just going to try and smoke test this thing. But in order to do a smoke test, there is this one bit of programmable logic, which goes right here. And that is a GAL 16V8. That's what they look like. And as I mentioned in a previous video, if I were doing this back, in the 80s. Oh, look at the date codes on these chips, by the way. 1977. Let's see. This is 84. This is 79 there, I think. There's a couple of new chips, but I used vintage chips where I could because I had them. And so what was I saying? Oh, yes. Back in the day, I probably would have used a, say, 32 by 8 bipolar PROM there, programmable read-only memory, but I don't have any of those, number one, and number two, I don't have anything to program them with. These GAL 16V8s can be programmed with this modern-day device, so that's what we're going to use. 64K by 8 EEPROM, but we only use, we only map 44K of it into the address space. There's 16K of RAM, and the other 4K is for the I/O space because the 6809 uses memory mapped I/O. I made a little diagram here of the memory map. The RAM is the first 16K, and then the rest is ROM except for the I/O, which goes in at CXXX in hex. Okay, so we've got to decode the memory addresses so that we're enabling the right chips when we access certain locations in memory. And to do this, I have used this program called WinCouple, which I found online, available for nothing. Oops, clever. WinCouple. This is the Atmel version. I don't know. It's a free download. And you can see, or not, depending on depending on how the screen looks. You can see in here that I've laid out as a comment the memory map. And then we have our input pins defined. Pin 2 is read-write. Pin 3 through 6 are A15 through A12. A15 being the high-order bit. So there's a high 4-order address bits. I had a couple of extra input pins, so I put the clock signals in there, although I don't use them. But, I'm thinking, well, maybe I'll figure out a use for them somewhere, somehow. The output pins, pin 19 is ROM, and okay, so these are active low except for this last one, which is active high. So that's what, there's a little exclamation mark there, which you may or may not be able to see. ROM, I/O, RAM, read RAM, write RAM, chip enable RAM, and read. So, that sounds a little weird. What's going on with RAM versus CE RAM? Well, the way this thing is designed, and it uses the, it will, attempt to make use of the Don Lancaster's cheap video cookbook methods. So there are times when you enable the RAM when you're actually reading ROM. Okay, so that's for the chip enable signal. The RAM signal is just when the processor is trying to read or write the RAM. CE RAM is if you're accessing the RAM or you're running in what's called the scan code. And we'll probably get more into that down the line as we get into the programming of this thing. And then there's an inverted read signal, which is just the inverse of the processor read-write signal. Anyway, the logic is down here. And so that's what we want to put into our GAL. Now, there's the GAL. This is a GAL16V8D from 15LP from Lattice Semiconductor. Okay, with a date code of 19. Well, I don't know where the date codes are on this. It's a C638B18. I don't think that means 2018. I don't think the 18 is 2018 because I don't think Lattice makes these chips anymore. If Lattice even exists, if they haven't been absorbed by somebody else, you know how that all works. Okay, so I'm going to put that in the programmer. Well, let's wait. Okay, so we set up our definition file here. And then we hit F9, and that compiles it, okay? That compiles it to something called a .jed file, okay? Which is what the programmer wants. Okay, so then I take that JED file, and I'm going to copy that over to my working directory. And it's exactly the same as what's already there, but that's okay. And then I have this program that I downloaded as well, which is called JED2EQN, which you can use to verify that it's done it right. So that creates a .eqn file, and then we can view that, and you see the equations, and they may look slightly different than what I entered because it munches them around a little bit, but I can assure you those are the correct equations. So now that we've done that, verified it, compiled it, we verified it, now we can burn it. So we put that in our PROM programmer. We bring up our PROM programmer program. Select the IC is a GAL16V8D file. We're going to open, that .jed file. Okay. And erase before, verify after. I don't know what this encrypt thing is, but we're going to leave that enabled by default. I use the defaults wherever I can, so I don't have to think about it. I did turn off the lock bit here, though. I think that was on by default, and it's like, what, does that prevent somebody from reading it out? I think, you know, I don't care. So, program, it erased it, it programmed it, it verified it, and it says programming successful. So there you go. There's our decoder chip. And we can put that right in. That'll go right in there. And then we'll head over to the logic analyzer and see if this thing actually does something. We'll do a smoke test. Oh, what I've also done is here in the EEPROM, I've put a little test program, and we'll take a look at that in a minute.